Okay, in the previous video, I think we have covered how to get the reference for these animation sequences and how to include those stuff into our state machine. And now I think the remaining part is this transition, right? So currently all of these transition rules are empty. Here you can see it gives these warnings as well. And now let's implement those one by one. Right. So where can I start? Yeah, so first let's start from this jump sources onwards and let's progress step by step. Okay, so let's go to this transition and let's mark it as true, because either way, soon after we come from any of these state, it should directly go to this state conduit, right? And this state conduit onwards, we can apply multiple different transition logics, right? So by default, this is true. And as the first possible transition is this one, jump start. So I'll go there, right? And here, first we need to get the character state data. And if we are jumping, and if we have a valid jump start loop, plus if we have a valid jump apex, then we can enter that specific state. These are the three logics. We should have a jump start loop because it's going to enter this state, plus we should have a jump apex valid animation because it's going to finally enter this jump apex state once it goes to this specific sequence, right? So those are the three conditions that should satisfy to enter this state. And now I think we can play test this thing. Yep, I think it's still not playing. Well, ideally it should play. Let's try ignore these two pins. Still not play. Yeah, let me quickly debug and see what's the cause. Yeah, actually I found the issue. It was a pretty much simple issue. Well, basically inside this jump selector, just make this as true, right? Otherwise this conduit is not getting executed. Therefore, it doesn't execute any of these execution paths, right? So now if I compile and play, you can see the jump start animation is playing now, right? But it's keep playing the animation and it can't exit from that state as well, because we have to implement rest of the transition logics, right? Anyway, so first step is done. It's playing the start anim, and then it should play this jump start loop. So I don't need to implement any sort of specific rules here. Soon after it plays the jump start, once it finished, I'll play the start loop automatically. So make this as automatic rule based sequence and it will go to the jump start loop. And let's play. You can see it remains at the jump start loop. Okay. And then it goes to the jump apex state. Yeah. So there actually I think we need set of stuff that need to be implemented. Okay. Yeah, let me see. Yeah. So in order to support these transitions, actually we need to do some calculations. So I'll add a new function called update jump fall data and make it as thread safe, goes to the blueprint thread safe functions, and I'll go to this blueprint that save update animation function, and yeah, did we, yeah, maybe after this one, right, we can add this jump fall data function. Okay, and there, let's go inside it, and let's first check whether we are jumping or not. So if we are jumping, then let's create a new variable called time to jump apex, which is a float. Assign it to a new category called jump. So if you are jumping, time to jump apex should be calculated based on the get world velocity. Now break its pins. So we need to consider only the c-axis. So I'll get the float minus float here. Not this one, this pin. I'll reduce it from 0. And let's get the property access. And let's get the movement component. And there we should have a function called get gravity c. Yeah, this one. So it will give the gravity value for c-axis, and let's divide it, and then we will have the time to jump apex, right? If you are not jumping, obviously the time to jump apex should be 0. Something like this. Compile, save, and then let's go to that transition, this one, locomotion jump start loop to jump apex. Right, and there, let's get this time to jump apex, and let's check whether it is, like, let's say less than 0.4, and we have a valid jump apex animation to be played, then we enter to that specific transition. Compile and save. Let's play it again. I can say we are at the jump apex, right? Okay, and then what we can do is, then it will go to this jump fall, right? Let's implement that thing, and I think we don't need to specifically implement the transition logic, because soon after we finish playing the jump apex, it will go to the jump fall loop, right? So I'll make it as automatic rule based transition. Compile and save, and let's play. Now you can see we are at the falling state. Okay, and then we enter to this fall land, right? In the fall land, actually we should calculate what is the ground distance, right? Because when we are closing to the ground, only we are playing that specific fall land animation. So now let's see how we can calculate the ground distance. Yeah, so for that as well, let's create a new function called set ground distance, right? So in order to determine the ground distance, actually we need to do some traces as well, so therefore we can't push it to the thread safe animations, right? So it should be executed atomically for in our daemon thread. Therefore, it's not a thread safe function. Instead, it's categorized as a not thread safe function. Right. Right. Now let's implement it real quick. Right. So we have the reference for character. Right. So let's check whether we have valid reference for character. If we have it, let's get the capsule component and let's get capsule half height, and I'll add some offset to it as well. Let's say 20, right? And I'll promote it to a local variable called cap half height. Right? We need it to determine some of the line trace related calculations, so I'll keep this as a local variable. And let's do a line trace by channel. The channel should be visibility and ignore self, and we need start and end vectors. So for the start, let's get the actor location, and I'll add the capsule half height to it, but instead of adding it, we can do some calculations. So let's multiply it by -1, and let's get the up vector, get actor up vector. Yeah, let's get the actor up vector, and let's multiply it using this up vector. So it will give the or it will expand this half height vector for us, and it will be expanded to the downside, right? Because we are multiplying it by -1. And I'll make this pin as to vector and add it to here and plus. So this is the starting location, and as the end location, let's add an offset to this location based on the up vector. So I'll multiply it for some plot, maybe like, let's say -1000, right? This is the trace distance, and I'll attach it to the end. Okay, and if we have a valid hit, which means we hit a ground or any sort of a physical flow, if so, let's break this thing, and as the distance, we can record it as ground distance. Okay, right. So maybe for the debugging purposes, I will make it as for 1 frame, or maybe let's say for duration, and let's call this function. So since this is a non-thread safe function, actually we can't call it inside our blueprint thread safe update animation function. Instead, we can call it for each frame at here, right? So first I will check if I am falling, right? If I am falling, only I need to do that tracing, otherwise it's just a performance hit, right? Because it's a line trace. So only if I am falling, I execute this set ground distance function. Compile and save. Let's play. Now you can see when I am falling, that line trace happens and it captures that ground distance, right? Okay, great. Now let's go to our transition, which is this one, jump. Not this one. For land, for loop to for land. This one. So let's get the ground distance, and let's say if it is less than 200, right? So you can tweak these values later on if you require, but I think 200 would be pretty much fine. And if we have a valid jump for land animation, then we play that for land. Compile and save, and let's play it again. Yep, I think for land animation is being played, right? But it's almost not noticeable. Yeah, see, you can see the fall land animation is there. You can check here. No, it's not playing. First, let's debug this ground distance value. Ladder print string here. This ground distance. Yep, it's less than 200, and it should play. Okay, that's fine. Let's check is valid jump fall land is true. Yep, it's also true. And in graph locomotion, for loop to fall land. Yeah, so actually the animation has been played, so I debug and see what happened. So basically at the jump for loop to jump for land we had this transition, and at the jump for land we have added this sequence evaluator, right? So inside the sequence evaluator actually we have to advance the time for that specific time frame that we are going to play, right? That's why actually the for land animation is not being played. Actually it is being played, but it's stuck at the very first frame, right? But just for the debugging purposes, if I add the sequence player with exposed pin and attach it to here instead of the sequence evaluator, and I'll make this as not looping, and if I play it now, you can see that fall land animation has been played, right? Okay, so now we have to advance the time inside this update sequence evaluator for the jump fall land, right? So as the on become relevant, I'll add a new binding, and I'll name this as setup fall land animlay, and move it to this anim node functions, right? So I'll get the node, convert to sequence evaluator, and at the initial step, at the initial frame render, I'll set the explicit time as 0, right? And then at on update, let's set a new binding called what? Called update all land anim layer. This goes to the anim node functions category, and there Let's get the convert to sequence evaluator, or this one, this pure function, and let's advance time, and the context is update context. Okay, so later on actually we can add sort of like distance matching for our animations. I think some of our animations have distance match based curves. For example, let's say inside this for land, yeah, we have this ground distance curve, right? So later on, when it comes to the distance matching section, I will show you how to implement much more realistic jump placement based on this ground distance curve. But for now, we can simply advance the time, right? But I'll add a to do here called add distance matching for jumps, right? So later on, when it comes to the distance matching stuff, we can simply add those features to here, right? Okay, so now on become relevant is done, on update is done. So let's play test it again. Yeah, now you can see for land is playing. Great. Okay, then it should go back to the cycle edges once the for land has been completed. Therefore, let's implement this function and let's get we need to determine whether we are on ground or not. So how to do that? Yeah, we have a function called update character state data. Here I'll use this pin and let's get the property access, get movement component, and there we should have a function called is moving on ground. Yeah, and let's promote this to a variable called is on ground, right? This should go directly to the character state data, and I'll add that pin to here. Compile and save. Let's go jump back to the for land to end in air transition rule and get this variable O. Let's get the property access pin and get movement component. So either we are at flying state, right? It should go back to the end in air state, right? So this may not required right now, but later on when we are adding much more dynamic capabilities for our locomotion system, it would be nice to have this check here as well, right? But if you want, you can remove this thing, right? Even this tool would be enough. Okay, so it should go to this state conduit, and inside this conduit we should mark it as true, otherwise it may not execute it. And this state conduit has only a one outgoing edge, which is this one, right? So it should go to the cycle state if it has an acceleration, right? Which means we are moving. And additionally, we may not move, but we are remaining at idle state. So in such scenario, let's add a second transition, which is priority level 2, and this is simply mark it as true. Okay. So if you add the idle state, it will execute this transition rule. Or if you are moving, then it will execute this transition rule. Actually, either way, it is executing both of these transition rules, but what matters is based on the priority order, which one become true at the very first instance, right? Then either of them is true, it will make this transition to this cycle alias. And the cycle alias is actually pointed to the cycle state, which means it will play the animation sequences at here. Okay, let's compile and save. Play it again. Now you can see we have the basic jump setup, right? So it is jumping properly. So if I'm at the idle state, it goes to the idle state. And if I'm moving and jumping, still it do the proper transition. Right. And I think maybe we can disable this trace, right? And test it back. Okay, it works properly. Right. Actually, the basic stuffs are done, and ideally it's worked properly. But we have some other transitions that need to be implemented as the countermeasures. Like let's say in case if some of these states are in inconsistent or invalid state because of we don't have a valid animation to be played, in such a scenario it should still handle the animations properly without halting at a specific state, right? So I think let's add those countermeasures and some of the improvements as the fourth part of the tutorial. Otherwise this one will also be pretty much long, right? Okay, so I'll see you in the fourth part, and probably that would be the last part for this jump features. Okay, I'll see you there. Thank you.